Welcome to the second part of our AI literacy journey: machine learning, deep learning, and generative AI. Artificial intelligence isn't magic, it's powered by systems that learn from data. Machine learning is the foundation, where algorithms find patterns and make predictions from experience. Deep learning takes it further, using layers of artificial neural networks inspired by the human brain to recognize images, speech, and complex behaviors. And then comes generative AI, models like ChatGPT, DALL-E, and others that can create new text, images, music, and even code. Instead of just analyzing data, they generate new content, reshaping how we work, learn, and create. In this section, we'll explore how these technologies work together, why they matter, and how they're transforming industries around us. Machine learning is the science of getting computers to learn and act like humans do, and to improve automatically through experience. Traditionally, data was used mainly to describe what happened. This is descriptive analytics. Then we moved a step ahead, asking why it happened. That's diagnostic analytics, helping us understand the root causes. With predictive analytics, we began forecasting, asking what will happen next. And finally, prescriptive analytics helps us decide how to make it happen by recommending the best possible actions. Machine learning and AI power this top level of analytics, enabling systems to move from observation to intelligent decision-making. Let's look at how machine learning differs from traditional rule-based systems. In a rule-based approach, humans define the logic. We write explicit rules. If this condition happens, then perform this action. Every possible scenario must be coded by hand. The system only knows what we've told it, and it cannot improve on its own. In machine learning, we take a different path. Instead of programming the rules, we provide training data, examples of inputs and outputs. The algorithm then learns patterns from this data and creates a model. When new data arrives, the model applies what it learned to make predictions or decisions automatically. The key difference is that in rule-based systems, humans teach the rules. But in machine learning, the system learns the rules from data. Machine learning can be broadly classified into three main types: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is like learning with a teacher. Here, we train the algorithm with labeled data, meaning we already know the correct answers. The system learns the relationship between inputs and outputs, such as how time of year and interest rates can predict housing prices. Unsupervised learning is more like exploring without guidance. The algorithm looks for hidden patterns in data without being told what the correct output should be. For example, grouping customers with similar buying habits or demographics. Reinforcement learning is learning through experience. The system interacts with an environment, takes actions, and learns by receiving rewards or penalties, similar to how we learn from trial and error. Together, these three learning types form the foundation for how intelligent systems understand, adapt, and make decisions. AI breaks down into two fundamental yet very different approaches: discriminative AI and generative AI. Understanding this difference is key to understanding the future of work and technology. First, let's talk about discriminative AI. You can think of this as the judge. Its single job is to classify or distinguish between different kinds of data. It answers a yes or no, or an A versus B question. Is this email spam or not spam? Is this transaction fraud or not fraud? Is this picture a cat or a dog? Discriminative models are trained on labeled data to find the dividing line, the decision boundary, that separates these classes. They are the backbone of most traditional AI systems, excelling at prediction and detection. Now let's look at generative AI. This is the new star on the block. Think of it as the creator. Its job is not to classify, but to create new things that never existed before, yet still look or sound completely real. How does it do this? By learning the deep, complex patterns and structures of its training data. Generative AI is what powers tools like ChatGPT, which writes human-like text, and DALL-E, or Mid-Journey, which creates stunning new images from a simple text prompt. It even creates the hyper-realistic video content known as deepfakes. So, what's the simple difference? Discriminative AI is a filter. It takes data in and gives you a label or a prediction out. Generative AI is a factory. It takes a prompt in and gives you an entirely new piece of content out. They are two sides of the same coin, and increasingly they work together. One to predict and judge, the other to create and innovate. The most powerful AI solutions often use both to balance creativity with control and accuracy. Have you ever wondered how AI can write a professional email in seconds, summarize a 10-page report, or even craft a heartfelt poem? The secret behind this magic is something called a large language model, or LLM. A large language model is like a superpowered text engine, an AI trained on massive amounts of text from books, articles, and the internet. Its strength lies in understanding language patterns and generating new content that sounds natural, relevant, and human-like. At its core, an LLM works through three simple ideas: the request, the context, and the example. The request is what you ask it to do, like summarize this document or write a marketing email. The context is the vast world of knowledge it has learned from, millions of sentences, topics, and ideas. And the examples are what help it recognize patterns, so it can predict what comes next and generate a response that feels intelligent and tailored. So, what can you actually do with an LLM? The answer: almost anything that involves creating content. It can generate text, writing articles, stories, or business communication. It can generate code, assisting programmers with logic and syntax. It can even support image and audio generation, creating visuals or voices from simple descriptions. If it involves creativity, language, or ideas, an LLM can help bring them to life. Some of the world's leading organizations are shaping this revolution. OpenAI, the creator of ChatGPT, Anthropic, known for safe and responsible AI, Meta, building open source models, and Cohere, bringing AI to the enterprise world. Large language models are not just tools, they're creative partners, amplifying human potential. They empower us to communicate, create, and innovate faster than ever before. The vast majority of modern large language models, LLMs, are built upon the transformer architecture, introduced in the groundbreaking 2017 paper, Attention is All You Need. The key innovation of the transformer is the self-attention mechanism, which allows the model to weigh the importance of different words in an input sequence, capturing context and long-range dependencies far more effectively than previous architectures like recurrent neural networks, RNNs. Within the transformer framework, three main architectural patterns have emerged, each tailored to specific types of tasks. 1. Encoder-decoder architecture. This is the original architecture described in the Attention is All You Need paper. It consists of two main stacks of layers. The encoder. This part of the model processes the entire input text at once. Its job is to read the input sequence and build a rich numerical representation of it, capturing the contextual meaning of the words. It is bidirectional, meaning it can look at words that come before and after a specific word to understand its context. The decoder. This part takes the encoder's representation and generates the output sequence one word at a time. It is autoregressive, meaning each word it generates is based on the words it has generated so far. How it works: imagine you're translating a sentence. The encoder reads the entire English sentence to understand its full meaning. Then, it passes this understanding to the decoder, which begins generating the French translation word by word. Best for tasks that require transforming an input sequence into a new output sequence, where a deep understanding of the source text is crucial. Machine translation, e.g., English to French. Summarization, e.g., condensing an article. Question, answering, where the context of the question is key. Examples: T5, text-to-text transfer transformer. BART, bidirectional and autoregressive transformers. The original transformer model, key components of LLM architecture tokenization layer, converts raw text into tokens. subword units, for processing. Embedding. Layer maps tokens to high-dimensional vectors. Transformer blocks. Core computational units using self-attention mechanisms to model relationships between tokens. Positional encoding adds information about token order to embeddings. Output layer converts final hidden states into probabilities over the vocabulary for prediction.